What's up, PreCalc? Here we are with lesson 3.1. Again, continuing our look into just the basic graphs of many functions. Today we have the exponential function, a to the x. Let's see here. Exponential functions and log functions coming up next, and these functions are examples of transcendental functions, big fancy words there. Okay, for f of x equals a to the x, the exponential function with base a, and if a is greater than 0 and not 1, and x is any real number, then these things will be true. Okay, well, why not 1? Well, because if the base a is 1, then it's just going to be 1. 1 to the whatever power is still just going to be 1. It doesn't move at all. So that would qualify as a constant function and not an exponential function. Alright, so once we have a bigger than 1, or not 0, bigger than 0 and not 1, we're going to have some movement. Okay. If it is going to be a big number down here, like 4, it's going to grow pretty quickly. If you had a smaller number, like a decimal that's between 0 and 1, it's going to be coming down pretty quickly. Alright, our domain, negative infinity to infinity. It's going forever left and right, no problems there. Our normal range for just the base level one, where a is bigger than 1, our range is going to be greater than 0, up to infinity but never quite hitting 0. We're going to cross at 0, 1. Anything to the 0 power is always 1. It's increasing the whole way. Our asymptote is at 0, our horizontal asymptote there, and it's continuous. Okay, if we have a to the negative x, or if this was a decimal between 0 and 1, it's going to be coming downhill like this. Again, domain, negative infinity to infinity, range 0 up, greater than 0, still crossing at 0, 1. This time it's decreasing, and we still have a horizontal asymptote. Okay? So just as an example, if you had y equals 2 to the x, alright? 2 to the first is 2. 2 squared is 4. 2 to the third is 8. 2 to the fourth, 16. It's going to keep getting bigger and bigger and bigger. Alright, well now, if it was 2 to the negative x, or if it was a half to the x, alright, a half to the 0 is 1. A half to the first is a half. A half squared is a fourth. A half cubed is an eighth. If you go backwards, now we're going to get bigger. Because half to the negative first would be 2. A half to the negative second is going to be 4. It flips it upside down. Okay, on the same coordinate plane, sketch each function. We'll just look at it on our calculator plane. 2 to the x and 4 to the x. Alright, so the first one we had there was 2 to the x in the blue and 4 to the x's in the red. And you can see they're basically about the same thing all the way up to this point, and then they start showing a significant difference here, where the blue one's a little more flattened out and slightly slower rate of increase, and that red one, once it crosses the y-axis here, it's going pretty steeply up. Alright, 4 to the x, if x was 1, is going to be 4. Squared is going to be 16, and we're taking off pretty quickly. Okay, so the bigger that base number is, the faster that thing's going to grow. In many applications, a convenient choice for the base is the irrational number e. This is called the natural base, and later on when we undo it, it'll be the natural log, but we're not there yet. The function given by f of x equals e to the x is called the natural exponential function, and its graph is shown there. Still basically the same thing, basically the same path. Be sure you see that for the exponential function e to the x, e is the constant and x is the variable. Okay, e is a letter, but e stands for a number. Kind of like pi is a symbol that stands for a number. E stands for a number. It's a number. It's not the variable. Okay. Example 5. What's going on with these? So try to remember your same rules of transformations and how they would apply to these a to the x graphs, these exponential functions. So the dotted one, every time, is our just standard y equals 3 to the x. And then kind of like the light gray solid line there is going to be the new mystery function. And you kind of have to guess here or look at it and come up with what was the shift and then write that equation. Alright, so on our first one here, top left, going from this one to this one, it looks like we just went down 2 lines. So we just went down 2, so that would be f of x equals 3 to the x, big minus 2 on the back. Okay. Top right. Tough call here, but to me it looks like we just moved over 1 to the left. It's tough to see it down here, but like as you get more towards the vertical stuff, from here to here, we just went 1 to the left. Okay? So, remember with left and right, that's got to be up there with the x. So this gets a little tricky up here in the exponent. 1 to the left, so that's opposite of what you would think, so it's going to be plus 1. Alright, bottom left, it looks like we just flipped it upside down. So that's going to be a negative to the whole thing on the outside. So this is going to be negative in the front. Excuse me. Negative in the front, 3 to the x. We reflect it over there. Flip or reflect. Alright. And then this one, it looks like we are up 1, 2, well from here, 1, up 2, up 3, up 2, here because they were flattened out at 0, and here we're flattened out at 2. So it's up 2. It's also flipped left to right. Do you remember how to do that? Okay. So we got our y equals 3x, and then we have a plus 2. How do we flip it horizontally? Now the negative is just on the x up here. Just applied to the x, and that's going to flip it horizontally. Let's check it out. Make sure we got this. Y equals 3 to the x. And then let's go with 3 to the negative x plus 2. So there's our dotted one. And hopefully we get this other one. Beautiful. Coming down just like that. Alright. Exactly what we have over here. Perfect. Awesome. Alright guys. That's all we got for today. Just the basics of those graphs. Let's take a look at that homework and let me know if you have any questions. Thanks a lot.